Hello, this is Unit 3, Day 4, Notes on Projectile Motion Word Problems. So what we're going to look at first is being able to analyze a graph. If you can analyze a graph, the rest of it should make sense. So keep in mind we're talking about quadratic applications. So everything we see is going to have the shape of a quadratic function, parabola, etc. Okay? For what we're doing for projectile motion, they're all going to be facing down. It models throwing an object into the air, and the ball or object is going to come back down. All right. So the first thing you should be able to do is analyze a graph and look at a graph. So this first page, some of you might be able to look at this and answer these questions and be fine. Okay. So if you feel comfortable trying that, go ahead and pause the video. Try to answer these without watching the notes. All right. But if you're not sure, you don't really have this is kind of confusing, that's fine. It's the idea. We're looking at the notes. We'll go through it together. Okay? So, if you're going to try it on your own, pause the video now and then come back and check your answers. Okay? Everybody else stay with me. Okay? So, we're looking at a ball thrown into the air. Okay? The first thing you got to realize about a graph and about projectile motion, time in seconds is our x value. That is our independent variable. Height is always the y. Okay, where height is a function of time. How high it is depends on how long it's been in the air based on its velocity and original height, which we'll get into in a little bit. All right, so you should be able to analyze this graph from there. So that's the first thing to know, x and y. All right, and then each of these intervals here, if you see this 64, well, there are 4 intervals here, 1, 2, 3, 4. So if you divide 64 by 4, you know that each interval represents 16. Okay, so our variable is in feet, so that represents 16 feet. All right, that's the next thing. So that way you can analyze this graph a little bit better, a little more specifically. Okay, all right, last, when you're answering these questions, the units matter. You can't just say 1 or 2 or whatever. You've got to say feet or seconds, so we know that you know what you're solving for. All right, so let's look at this. The height of the ball after 2 seconds. So go over to 2 seconds, see what the height of the ball was. Okay, so that's one line below 256. Well, we established that each line is 16. Okay, so that means it's 256 minus 16, so the height is 240 feet. All right. When will the height be 192 feet? Okay. This is kind of tricky because you look at it and you say, okay, well, it's just this here and I'm done. Well, where else is it 192 feet? It also happens over here. So you got to make sure you're paying attention to both of those. Okay. So it's 192 feet after 1 second and after 5 seconds. Okay. What is the ball's maximum height? So you're looking at the y value. This is the highest point up here. That's at 256 feet. When does the ball reach its maximum height? So then you look at the x value. Okay, the x value is always the time given in seconds. So that's at 3 seconds. After how many seconds does the ball hit the ground? All right, hitting the ground means y, or the height, equals 0. Okay, so you're looking at the seconds when y is 0. All right, so that's over here. Ball hits the ground right here. That's at 7 seconds. What was the ball's initial height? Where did it start? Where did we throw the ball from? At what height was it thrown from? Okay. So we go to the beginning of the graph and we look right there. So it's one line below 128. So 128 minus 16 is 112 feet. Okay. For what interval of time was the ball rising? Okay. So from what point to what point was the ball going up? That's going to be from the beginning to here, to its max height. So that's from 0 seconds to 3 seconds. So we write that interval the same way we've been writing intervals the whole time. So from 0 to 3, the ball was going up. So I know it landed at 7 seconds. So it stopped falling at 7. Well, it started falling at 3. That's the rest of the graph. Okay, so we're looking at increasing and decreasing in terms of this ball being thrown as rising and falling. For how many seconds will the ball be more than 192 feet above the ground? We could say, what interval was the ball above 192 feet? It's the same answer. All right, so go back up here. It was at 192 feet at 1 and 5 seconds, which means it was above 192 feet during that time. All right, so it was above that more than 192 feet. It doesn't say more than or equal to. This is very specific. Okay, so you have to say from 1 second to 6 seconds. That's not right. What was it? It was 1 second to 5 seconds. Excuse me. So from 1 to 5 is the interval, which means it was in the air for 4 seconds. All right. Okay. So let's move on to writing an equation. So this is what we're looking at. Okay. We're looking at projectile motion. These are the parts you got to keep in mind. All right. This is always a function of time. Height is a function of time. Height is the y value given by time, which is your x value. Okay. Let's look at this backwards. Okay, this h sub o term, that is your initial height. Height. If it says the ground, that implies 0. Okay? V sub o is our initial velocity. If it says it was dropped, that implies 0. If it says thrown down, your initial velocity will actually be negative. Okay? Thrown up, the initial velocity is positive. Okay? You'll notice this negative 16 t squared. That never changes. What do you think that represents? Think about the physics of the Earth and space and the universe. Okay, I know this is math. All right, but think about what will never change. You're talking about projectile motion and things falling towards the ground. All right, that represents gravity. That never changes. So if you just drop something, the gravity will still act on it and bring it down towards the Earth. Okay? All right, so that negative 16 t squared represents gravity. That never changes. All right, t. All right, again, that's time given in seconds. That's our x variable. Height, or h of t, or y, that is our height given by how much time has passed. Okay? So, given a problem, can you write the equation? So, the example, an object is launched upward from a platform 15 feet from the ground at 128 feet per second. Write the equation that models the height of the object as a function of time. So, height as a function of time will be equal to negative 16t squared. I'll do that. That's the easy part. It's always going to happen. The next part is the initial velocity, right? V sub o of t, or times t. All right, so what's the initial velocity? 128 feet per second. So 128 t plus, this is the initial height, 15 feet. Okay, that's your function. All right, so try this next one and see how you do. All right, so height is the function of time. H of t equals negative 16t squared plus 40t plus 96. All right, so you should be able to write the equation given a description. All right, the next thing, you'll need your calculator for this. All right, go ahead and pause the video and get your calculator out if you haven't already. All right, so if we give you an equation in this format, in this notation, you should be able to plug it into your calculator and analyze it. Right? So go ahead and put this into the calculator. Oops. So you're going to have y equals negative 16. On the calculator, instead of t, you can use x. Okay, it's all going to work out the same. You can use x instead of t. That's okay. All right. So negative 16x squared plus 8.4x plus 8. Okay, so that's your function. We're going to go ahead and graph it and see what it looks like. I tried to give you a graph that fits nicely in this window. That might not always happen. We'll help you with that if you have a hard time fitting the graph in the window. All right, but for our purposes today, this should fit nicely. If it doesn't, if you don't see it how I have it up here, hit window, or excuse me, hit zoom, and option 6. Okay, that should bring the graph up nicely. So what is the initial height? Okay, you shouldn't need the calculator for this part, right? The initial height is right there. So the initial height is 8. All right, so this is, I want to emphasize here, don't just write 8, okay? Write 8 feet. We need to know that you know we're talking about feet and what the units are, not just 8 as a unit, okay? All right, maximum height, and when it meets or when it reaches a maximum height. All right, this is just another way of asking for the vertex. All right, the maximum height is the y part of the vertex. When is the x part of vertex. So you need to go to your calculator, do second, calc, maximum, and do it the same way we found the maximum before. So go a little bit to the left of the vertex, go a little bit to the right. There we go. Press enter twice. Why is it asking for my second curve? Must have pressed the wrong one. Okay, hold on. Second calc 4 is my maximum. Okay, sorry about that. So go a little bit to the left and a little bit to the right. Enter twice. You should get your maximum. So the maximum occurs at, if we round to the 100th, 0.26 seconds. And the actual maximum height is, we'll call it 9.10 feet. Okay? When does it hit the ground? Again, ground implies 0, or y equals 0. So all you're doing for this is solving for t. Okay? So go to second calc, 0. Now, you only want the positive one. The negative one's not going to do you any good because we can't go back in time. We just want the positive value counting forward, okay? So it means the left bound of that positive 0. Then the right bound, and then enter again. So it hits the ground after approximately 1.02 seconds. Okay? So that's how you use the calculator. These are all things you should be able to do with projectile motion. Okay? Please make a note of any questions you have, and we'll see you in class. Thank you.